Welcome from the Datron headquarters in März. As Mr. Katal said, my name is Mark. I'm applications engineer at Datron, and I would like to give you a little bit more of an insight into our axis 4. So adding an additional axis to a 3-axis system, that's the goal. What are the capabilities? What are the benefits? Where are my restrictions? So we're gonna cover all of the hardware perspectives, all of the software ends, and see what kind of applications make sense to put on a 4th axis and where it can be beneficial in your shop and in your daily production business. If you have signed up over the last days for this session, you have probably seen that there was a second speaker supposed to be here with me on site. Unfortunately, my colleague Simon is ill, so we hope the best for him. Get well soon, Simon. And so for the moment, it's only me here, but I think I can give you most of the bullet points of this topic anyhow. So let's start. What is the axis for? Where can I use it? And what are the hardware components that I need for it? Like some of you might know, the axis 4 is an additional accessory for all the Datron 3-axis machines with a next control. So the latest control that we run on the machine. So it could be either the Datron Neo or ML Cube, M8 Cube. So it is basically open for all the machine types. What kind of components do I have and do I need for it? We have the main module, that is the axis itself. I hope you can see this. The camera is kind of heavy, so I couldn't get any closer to the camera without destroying anything. Anyhow, I got this axis, that's where the motor sits. I have a clamping device on it. That's a 3-jaw chuck, in this case for round parts, for round stock parts. Alternatively, we could also use a centric bias center clamp with steel jaws. They can be both turned in directions, so different sizes are possible. That's the main thing that we need. Optionally, we can have and use a tailstock unit, which is mounted on a separate base plate. So depending on how large your machine is, you can move the tailstock in the X direction, depending on the part size that you want to clamp. And this sits on a guide rail here, which I can clamp. So these are the main components that I need. The base connector adapter for the axis itself can also be used with any special device. So if you want to create your own device or have any special kind of application that doesn't fit either on a 3-jaw chuck or on a centric vise, you can adapt this just to whatever you need in particular. So using the standard clamping components gives you a lot of freedom already. No matter if it's a round part or if it's just flat material that you want to index and want to operate or machine from different angles, you can definitely cover most of these applications with the standard centric vise or 3-jaw chuck. So putting it on the machine means you have to calibrate it. We need to make sure that the axis is aligned, is perpendicular to all the axes, like the rotational axis is running in a round shape in relation to the machine system. So how do we get there? So if you mount this axis for the first time, there is an automatic calibration cycle. So it uses the 3D probe of the machine, which like almost all the machines have, and like a ground bar and a steel bar, which I have here. This steel bar, so the probe touches it off on different positions and calculates the angle deviation and tells you if you need to adjust it mechanically, or later on it's just compensating it on the software end. So let's quickly look at a video how this works. So this is where we see the probe coming down and touching this round bar from different angles and on different positions. And with these values, the machine is able to compensate everything, to realign the angular deviation, and so on, so that you can be sure that the axis is locating your parts correctly afterwards. Now, just for my personal interest and for our general interest as a machine builder, to all of our viewers now, do you already use a fourth axis? So we have a little survey here where you can take part. So I would just open this up. So just give me a short feedback if you're already using a fourth axis or not. It's also in our interest to see which direction is our customer base going, and is it something that is very common or not. So I'll keep this open for a few more seconds, and afterwards we can see if there's a big, like if there's a majority using it or not, or if it's more or less equal. So I got some results here, which is 50-50. Now that surprises me a bit, because usually it's less people that are already using a fourth axis or not. So 50% is quite a bit, definitely. So let's say we have mounted this the axis on the machine and we want to get it to an application. So the first thing that you get in mind is what do I use the axis for? On which part? Does it have to be a cylindrical part? Is it something that I would usually put on a lathe or on a turning machine? we figured out here in our tech center that it's more a thing of a different approach to three-axis parts, actually. So I'll show you a part that we were supposed to make here in our demo room. And if you look at this part, you would probably not think that this is something that could be done on a fourth axis. You would usually think this is something that goes into a mechanical bicycle and then just realign it later on. So if we get a closer look to this part, we can see this is a microelectronic housing. It has a cavity on the top. It has two long holes on the sides, and it has 4 pins and a long hole on the back side. So in fact, we have 4 sides to work on, 4 sides that need to be machined, which means I could use a large plate, putting it on a vacuum and make one side in one shot and get hundreds of parts out of that. But from that point on, I have to reorientate it, to put it on a vise, to put it in a special fixture, and make sure that I can machine all the remaining sides. So that's a lot of handwork and just setting parts up. As the request in this particular case study was that the amount of parts was not too high. It was like always between like 100 and 300, but similar parts that they wanted to make, we thought an approach with the Axis 4 would be ideal. So let's just look at the CAM program again, and I'll show you what we've been doing instead. So here's my illustrated Axis 4 with 4 parts mounted in one plate. So what we can see in this yellowish color is my stock material. Then we see 4 of these little housings. And if we get a closer look later on to our tool paths, we can see that we can do the top with the cavity, we can do the bottom with the pins, and we could do 2 sides or 2 long holes on each side. So we can do a 3-side machining in just one shot. Let's just take a look at the video, how this was machined. And I think that will give you a good understanding about that kind of different approach for these parts. So we're clamping the stock material here. And my machine is doing this indexing movement. So it's going like it's rotating it up to 90 degrees, up to 180. So the tool can reach all the major features on this particular part. Now you can see it's upright for the long holes. And at the very end, we just leave a little tab that holds the actual part to the stock tube. Like, this is extremely useful when it comes to breaking the parts off the stock material, and at the same time putting it back onto the vise for that final remaining operation. So yeah, we could clearly see that in the video. We're breaking off the sides. We're doing 3 sides in one shot, and then an additional vise. Speaking about the vise, no matter on which machine you have mounted the axis for, no matter if it's a Datron Neo or up to an MLQ, it will always fit another a clamping centric vise on the table. So you have still the full flexibility of having multiple work holding solutions on your machine. So you can have the additional 4th axis, and it is still a 3 axis with the centric vise. Different example. This was something that we've done a couple of months or even years ago. That's an endoscopy housing. So that's a prototype for it. So there goes electronics in, there goes a little camera through, whatever. So the full inner round cavity, that big hole is done in this shot. The freeform surface, all the connections here for most likely like the switches or like the little holdings for the electronics, as well as the thread where the like the lens is mounted or whatever. Also with a tab, this tab is a little bigger as we use this for a sample part, so we don't break every part off. So we just kept it stiffer. That different one would be here. That's a C binding part with a very irregular shape. So even if you want to make this part on 3 axes, you will probably struggle to get to all the different positions, as we have freeform surfaces in this inner corner here. And there are the little tabs here and there. Probably see it better from the back side, like that. So you can easily break that part out at the end and just like grind off that remaining rest. So let's just see how we break out that little microelectronic housing and how it looks at the end. So once again, we have this T-shaped stock material left over, and we can easily break the parts out. So we still have that little tab, which is then faced off in the centric vise, and this is how the final part looks like. All right, one last 3+1 example. 3+1 means always this indexing position. So I do a movement first, and then my 3 axis is doing a feature. So A-axis movement and XYZ is always separate from each other. That's indexing. That's 3+1. And there's one last example that we got in a video before we move on. where we can speak about simultaneous movement. So there's also, that's like kind of a gearbox housing that needs, or that has different features from all the sides and chamfers all around. So we got face mounting operations, we got pocketing operations, we do some threads in it, and it's all done in one shot. So we have only the sixth side remaining, which can then be done in a centric box. There comes a chamfer tool, making the chamfer at the end. And then we can see that final part spinning in the rotation axis. Now the question that comes up all the time when we speak about the axis 4 is, how about simultaneous movement? So other than I just told before, indexing, doing a 3-axis movement simultaneously means all axes are interpolating together, X, Y, Z, and the A axis. You sometimes need this, especially if you have freeform surfaces, 3D surfaces like blades, like different like pumps or pump interior parts, all that kind of stuff. So sometimes you need this, you need that kind of degree of freedom to get there. And the answer is yes, of course, the axis can do that. So it depends on your CAM system, so you would not program this by hand. If we take a look at this sample part here, which is an extruder screw, so the pitch of this screw gets smaller further up, and this is something that we've done simultaneously. Unfortunately, I don't have a video for this part, but I got something else that explains and shows the capabilities and the dynamic of the axis itself when it comes to this simultaneous movement. And we see this crankshaft being machined. So there we've got this inner surface that is being finished off with a ball and mill, and like all axes are moving. So there's nothing standing still. Super dynamic. We do that on the Datron Neo. So on the smallest machine, you can see like on this roll up here. Yeah, so these are the capabilities, and it would be very interesting to know from you if you're already using a 4th axis, we know that, but for those that are using it, what is the amount of simultaneous work that you do on it? Because that's something that we are still struggling a bit to find out about. What is our customer base doing mostly on such an axis? Would it be simultaneous movements and work, or would it really be something that's just indexing, flipping parts, and doing the stuff from the first and the second operation? So let me just know how that how this is like going in your shop and in your business. It would be very interesting to know. So we have up to 30%, up to 60%, or like everything that we do is simultaneous work, which I don't think. All right. Yeah, and we also have a lot of customers that keep frequently using the axis. But coming back to that question, most of them, or that particular customer, is only using it in 3+1. So, and that's actually what the result is saying here. So, like everyone who has just answered that question is up to 30% with the simultaneous work. So yeah. Here's the results. So all of you are just doing a very small amount of simultaneous work. So speaking about that customer who's already using the fourth axis, the axis 4 on the Datron Neo, it's actually a customer that has a lot of Datron machines, makes us very proud. Thank you to the First Mold GmbH here in Germany for letting us get an insight of their production facility, and that's something I want to show you. Even that it's just not really focused on axis 4, but it's very interesting to see their production line. And yeah, here we can see the lineup of machines. There is one Neo and some kind of older machines there in a row from M8s, a lot of M7 machines, and because they have so many M7 machines, they keep giving their the machines different names, so they don't mix it up, and we're clear about about which machine they are talking. So it's actually quite funny because they use like movie characters, and in this case it's Homer Simpson or SpongeBob, or even on one M7 machine it's Neo from Matrix. Which can be a confusing thing if you have a machine that is called Neo. So not sure how this works out. Yeah, so one part they've been doing on their axis 4 is this handlebar. So that's something with a freeform 3D surface on it, and you can see the 2 screw holes. So this part gets attached to one of the to some housing, to some cases, or not exactly sure what it's used for. But also this done is in one shot, just on the axis 4. By the way, if you have any questions, there is a chat box in this window. So let me just know, and I will try to answer them. So let's have another look on the CAM side, about how to program it. What's like the approach? And I've opened up another part here in my CAM system, which is a truck for a longboard. You've probably seen one of our longboards that we've been cutting over at exhibition shows over the last couple of years. And this is just the truck that holds the wheels, made of aluminum too. So I have set up my axis once again with the so this is how I locate this part in the CAM system. So I can do machine simulation here. And as you can see here, we have different angles. We can operate it from the back side as well. And if I blind out my axis 4, I can just I think you don't see my screen. I hope it's getting better now. So sorry for the problems. So just checking on a screen here on my side if you see my split screen and my shared screen, and because we have a delay of like 15 seconds, so this could happen also. So sorry, we're back here. This is my part that I want to make on the fourth axis. You see we have different angles that we need to machine. We also need to machine the backside, and I have my axis 4 also in here, so I can see exactly how everything sits, how everything is being located. And if I now just want to, let's just say we want to face off this side. Then I can select my tool. This just takes too long. Let me just show you this. So my computer is obviously too weak to generate and handle all the all the equipment that I have now. So what I wanted to tell you is cutting this off in the fourth axis would be it wouldn't display my my fourth axis now. So I'd use this face here and there to leave the tabs, so I can do everything from all different angles, all the surfaces here. I can do the drill hole there. Just make sure that the tool is perpendicular to each face and to each hole. So my CAM system and my Post Pro will orientate the tool correctly, so it's always in the right angle. I need to check for collisions, obviously, and at the very end, I leave tabs here and there on these two positions, so I can just easily break the part out, just as we saw on the housing part before. So that would be a very, yeah, like a smart technique to avoid multiple setups. So you don't want to waste your time on doing multiple setups and making soft jaws for like different orientations. And with the Axis 4, you can just do that all in one shot. If you have any questions, just let us know. We can give you some consultants on the programming end as well. All right, let's see if there are some questions in the chat box. So on which axis does the on which machine does the Axis 4 fit? Like I said, from Datron Neo, smallest compact machine, that one over there, up to an MX cube. So no matter if it's an M8 cube, ML cube, it would always fit. It has to have a preparation for the axis, though. It is an axis. It needs an axis drive. It needs some cables and wires in the electrical cabinet. So it needs to have a preparation. This is very easy if you want to retrofit it on a Neo machine. So that can be even done by the customer itself. We don't have to send a service technician out. It's extremely well explained in all, like in the manual. So it's a thing from about like an hour or two, and you can retrofit the whole connections, all the electrics to your existing 3-axis machine, and then upgrade it to a 4th-axis machine. For M8 cube, ML cube, it has to have an internal preparation. So that's something that needs to be checked. Just make sure it has to have the next control. So if it's a machine with CNC control or HSC Pro control, there are different rotation axes, but not the Axis 4. So this is exclusively for the newer generation machines. What's the maximum RPM? The maximum RPM of this axis is, I think, between 100 and 120. So if you think about a mill turn application, that's probably nothing you would do on this axis. So it's just not fast enough to like represent a real turning spindle. However, depending on your CAM program, you can still do like round shapes and just use the combination of a tool that spins, which is your milling tool, and like a slow movement, like along the profile. So that would work. It is definitely not a mill turn accessory. So that's for sure. So it's more indexing, but still you can, what we just saw before, use it for having 3D surfaces and keep the axis spinning all the time. It's just not at a very high RPM. How about the connections to the machine? Yeah, that's what I've just covered before. And it might be something interesting to mention again. So once your machine has all the hardware and the electrical hardware in it, it is just plug and play. So once this has been installed once, you can just put the axis on the machine, hold it down with 5 or 6 screws, connect it to the table, let the calibration run, or execute the calibration run, and then your axis is good to go. So it's super comfortable and super flexible to get it off and on the machine again. And as I said, depending on your table size, you can still use other clamping devices as well. So yeah, that's basically everything the machine needs, so that it does not need any additional air supply or something else. It's just this. All right, what kind of other questions do we have? What's the maximum diameter? Yeah, great question. Which I actually forgot to mention. Very important note. The tailstock height, so the maximum height from the tip of my tailstock or the center of my rotation axis and the base plate is 55 millimeters when the tailstock is mounted. So maximum diameter that you can hold or machine and spin in the axis would be 110 millimeters. So that's maximum. Not even sure if the standard clamps here would even hold that kind of diameter, but you can still adapt it. So that's a very important fact. And because the base plates are separate from each other, the length can vary. So from as short as possible up to, if you put it on an ML cube and you put the tailstock right on the right side of the table, you could, in theory, mount like 1 meter, or I think it's 900 something in maximum. But in this special case, we would still have to check is the gearbox strong enough, is the torque high enough to move the part around. So if you have a big clamping plate or whatever, this might be too heavy, and yeah, the weight would just not keep the axis and the parts stiff enough. But that's just in theory. So we can easily do that. On the Datron Neo, this round bar was pretty much the maximum that we can hold because of the axis limitation, and this is 200 millimeters. So that's a very important thing to keep in mind. But on the other hand, having a part that is like 55 millimeters big, machining this on one of our machines with the tooling can be critical as well. So the limitations is probably not the axis at the end. It might be the tool length or the stiffness of your tools and stiffness of or chattering of during the machining. So that would most likely limit the entire process. Yeah, I think there are no more questions coming in. All right, then I think we're pretty much through all of this, and I hope that I was able to give you a good insight of this Axis 4 and open the mind a little bit in terms of how can I approach a part for the future? Will this be a great retrofit? And will this be something that could expand your capabilities working on the Datron machine? So as I mentioned before, it can be retrofitted for most machines. If we're unsure, just let us know and we check in the system. If you want to take a look at our previous web sessions, they can all be found under experience.datron.de. That's our web page where we have all the, we have our internal experience days where we did a lot of video sessions and live sessions covering not only Axis 4, we cover tools, we cover automation and different, even 5-axis kind of stuff. So so that's still available there. If you have questions, just let us know. Applications@datron.de or service@datron.de. Yeah, so I want to say thank you for the attention and spending your time with me and us here to learn something about this really great accessory. Like I said, if you want more information, just let us know. Stay healthy and see you hopefully next time. Bye.